Hey, how's it going? All right, so I recently made a circuit board from JLC PCB, and I've been doing this tinkering with Bluetooth, where I have basically I'm using this ESP32, and I'm doing some reading to this and writing to this using the Bluetooth BLE, like a native React app, and then this is C++ on Arduino. And the idea was I wanted to have a little board where I could have these digital terminals. So we have like D2, D3, D4, D5, and then just basically have it so, like, say you have this LED or a relay, you could use these terminal blocks and basically break it out. And I'm learning PCB design, so I'm always in this idea of like iterative, do small steps. So what I want to do is do like a retrospective. So in Agile, there's this idea of a retrospective, where at the end of like an iteration, you go and look back on the progress you've made, and you see what were the good things, what were the bad things, what are the things that need improved. So first thing we would do, what I noticed with this board is there is a concept called floating pins with Arduinos, and that's basically where in the open state, so basically like each one of these terminal blocks, you've got ground and a digital pin, and the digital pins have two values. They can either have like a high or a low, and the high is when you have VCC going to that pin, or low is where you have ground going to that pin. But what happens in the floating pin situation is where, not like right now, if it's open, it's an open circuit, so it could be like a 0 or a low, but really you're not actually reading the ground value, and it's indeterminate. So one of the things is need to fix a floating pin. The other thing that's really obvious now, let me get this, is I always do this basically. So I want to have a box that goes in this, and this is the power cord here for the USB, and look at this. So if I get my USB in here, it's basically right in front of my terminals. So what I want to do for the next iteration is, I'm thinking I need to flip this around. So to plug it in, you would plug it in from the back, because the end state is I want to have a nice little enclosure in here. With Bluetooth, you can turn things on or off. I actually have this idea for like a automated, or at least a project that I'm working with for like an automated testing fixture. Just kind of doing some POC, but basically you could have these digital pins test various other electronic applications. So let's go ahead and I want to go to Easy EDA. We're kind of designing it first, and I want to show you like the first schematic. And this is the one where you can see this is the ESP32, and I had to make this footprint. And we got like GPIO 15, which is going here, and I've got this net GPIO 15, 2, 4, 16, all these, VCC and ground. And what's nice over here is this is the circuit for these terminal blocks here. So if we go over here, terminal block 1, terminal block 3, and basically ground and a GPIO pin, right? Ground, GPIO pin. And then we're basically, if I go to this PCB, this is the actual layout for that. And then if we go view 3D, you can see that we've got our terminal blocks here. So we'll write this down. So the first one is like, we want to say like remove floating pins. Make sure charging port is facing the back, not towards terminal blocks. So that's pretty nice. And over here, actually, if we go to this one here, and like I said, I'm learning the schematics, is I have my pull-up resistor. So basically we have this as the GPIO 15 ground. And so basically now if it's in its open state, it's going to get VCC, or it's going to show high. And when it's closed, the voltage is going to go to the path of least resistance. So instead of going to GPIO 15, it's going to go whoop down to ground. And that means GPIO 15, when they're together, it's actually going to read a low, or that ground potential. So it's going to flip a little bit of the code. And then basically over here, this is going to be my next iteration, or at least the start of it. So I still haven't flipped, and I might need to do that, or we might try that. I haven't flipped the microcontroller, but I did add some pull-up resistors. So here, this is kind of a nice board. We got these resistors, and then now that's going to solve that floating pin situation. So we could do, just for the heck of it, I wonder how, if I just, boom, it just jacked up all my traces. So I did the auto router. So let's actually, I don't necessarily want to hose. So let's maybe do this. We are going to convert to PCB. Oh, I got some problems. Did I break something? Oh wait, this is my wrong sheet. This is the one where I wanna, let me save this. Save, no. And we'll convert this to, what the hell? What I'm gonna do is delete this. I just had this circuit with the no pull up. I think that'll solve. Just to show some of the issues with the existing one. So if it converts, so we'll know on the nets. Apply. So I don't want to have to redo this whole thing, but basically this guy here, these need to face the back. So this thing here needs to face the back, which is cool, right? And then these guys, so I'm just gonna try to organize these how I kind of want them. Here. Okay. So basically we want these here. I'm kind of just gonna place it close. And then we're gonna do something terrible that people, we're gonna use the auto router. Or at least we'll get it close. I want these guys. So space bar is again how you like flip them. So we're kind of getting our resistors, flip it, put our resistor here, flip it, here, flip it, and again these are to combat our floating pins. And then for now, what I want to do too is I want to put this over in the left, and actually in the right, I do want to have, I'm thinking about breakout headers. So that's at least something. So we could totally auto route this, which I want to try it. Auto router. Sometimes this works freaking awesome. You just cross your fingers and you hope the computer has their algorithm. 0 failed. That's pretty dope. I'll be fully honest, because this is routing it way nicer. So yeah, so this, if we go back, we just flipped. So like our big issue here where our charging is right in front of this. So now this is going to be in the back. And the idea is, I think with the enclosure, this will be all in a box, and you'll just see the terminal, these terminal blocks to kind of like push it in. That's the idea. So basically, let me save that. And And then you can do like view, 3D view, which is pretty sweet. So okay, so that's cool. So now our USB is going to be in the back, not with this. Okay, so then circuit retrospective. Something else I do want is I want to have a breakout headers for open pins, right? So if we take a look at this, this block is going to be a ground and like a digital 4, ground and digital, and these are digital pins, and we've got like 30 pins. So we've got some other like UARTs, SPI 2, SPI squared, S squared, I don't know, different boards. So I'm thinking like, let's see, like this board here is a digi one. Actually, like we've got these these headers match up with the pin, so I think that'd be pretty nice. So on this we'll have those headers. So breakout headers. Yeah, I think that's pretty good for the next iteration. We will see. I want to definitely be able to have like an enclosure. So like this needs to be thought out. We can do like 3D printed, but ideally we want it manufacturable. So we'll basically base it off existing model. So we'll get like off McMaster car, like an enclosure. So that is tinkering with Bluetooth part 3, I guess. We started with the hello world of using BLE and the Arduino, and we have 4 digital outputs and inputs that are now connected to the board, and we learned from this, and we will move forward. So yeah, that's the next one. We'll see you next time.